Hi, the Hall County School District is excited to announce the release of our Back to School ELA and Math Reconnect broadcast. Between August 12th and August 21st, the Hall County School District plans to release 6 ELA and Math video lessons for students in K2, 3-5, 6-8, and 9-12. Along with the video lessons, students and parents will have a list of supplemental resources related to the topic from the lesson. Students and parents can access these videos and resources on the district's Reconnect Hall website beginning August 12th. We hope students and parents find these instructional tools helpful in getting a jump start on learning for the upcoming school year. Welcome, and thank you for taking the time to get ready for a new school year in Hall County. The following reminders are super important as you and I begin working through this video. Number 1, use the resources provided to further your learning. Access supplemental resources using the link below the video. Resources that require a connection to your Hall County Google Drive account are noted on the list. Pause the video when needed to think about what you are learning. You may even ask yourself, do I know this already? Is this new information? Who taught me this in the past? Today's lesson is on factoring quadratic expressions. In the resource document below the video, you will find student notes to accompany this video and slide presentation. Please feel free to stop the video and make a copy of the notes if you would like to follow along. The standard we will be talking about today says, factor any quadratic expression to reveal the zeros of the function defined by the expression. The idea is that by the end of this lesson, you are able to factor quadratic expressions. The learning targets are found here. You and I are going to tackle these learning targets together in this video. And remember, don't be afraid to pause the video if you need a minute or two to think. Just make sure you come back when you're ready and you finish the lesson. Today's learning targets ask us to find the greatest common factor and factor it out of an expression, and rewrite a quadratic expression in the form ax squared plus bx plus c as the product of its binomial factors. We'll talk more about that as we go through the video. But remember, for this lesson, a will equal 1. Before we really investigate and accomplish these learning targets, let's try a warm-up. Pause the video and complete these 2 problems. When you're ready, press play. Let's look at question number 1. How did you do? You were asked to multiply 2x minus 1 by 3x plus 2. First, we would multiply 2x by 3x, and then 2x by 2. So 3x multiplied by 2x, and then 2x multiplied by 2. Next, we would multiply negative 1 by 3x and negative 1 by 2. So negative 1 multiplied by 3x, and then finally negative 1 by 2. 2x by 3x is 6x squared. 2x by 2 is 4x. Negative 1 by 3 is negative 3x, and negative 1 by 2 is negative 2. If you notice, the 2 middle terms are like terms. This means that they each have the same variable raised to the same exponent. So we're able to combine those by addition or subtraction. This means that we can subtract 3 from 4 to get 1 for the middle term. Therefore, 2x minus 1 multiplied by 3x plus 2 results in 6x squared plus 1x minus 2. Let's look at the second warm-up question. We're asked to find the factor pairs for negative 40. We know that 2 numbers are factors of a number if they multiply to give the number. So 1 and 40 is a factor pair, 2 and 20 is another factor pair, 4 and 10, and 5 and 8. Because we're looking for the factors of negative 40, we know that in order to get a negative number, we have to multiply 1 positive and 1 negative. So that means that one number in the factor pair has to be negative. So our factor pairs then would be doubled. Negative 1 and 40 and positive 1 and negative 40. Negative 2 and 20 and positive 2 and negative 20, and so on. Those are the factor pairs for negative 40. Next, we'll get into the lesson, factoring quadratic expressions. What exactly is a quadratic expression? A quadratic expression is a mathematical expression where the highest exponent, or degree, is 2. If you notice the examples on the right, 5x squared minus 6x plus 3. The highest exponent is 2. In the second example, 2x squared plus 7, the highest exponent is 2. And again in the third example, even though these are not in the same order, the highest exponent is 2. Therefore, all three of these are examples of quadratic expressions. So, in other words, a quadratic expression can be written in the form ax squared plus bx plus c. This is called standard form, where you have the squared term first, the x to the first power would be next, and the constant would be last. So in our examples, the first and the second one are in standard form. The third one is not. In order to put it in standard form, we would have to rewrite it with the 8 first, 8x squared, then minus 3x plus 9. Remember, for all of these examples, a cannot be 0. If a is 0, in other words, the coefficient of x squared is 0, we would not have an x squared term, and therefore we would not have a quadratic expression. And what does it mean to factor a quadratic expression? It means to either find the GCF. So as you will remember, GCF stands for greatest common factor, or the two binomials that were multiplied to get the expression. You have already factored negative 40. You multiply the factors of 6x squared plus 1x minus 2 as well, when you multiplied 2x minus 1 by 3x plus 2. The first step in factoring is to look for the greatest common factor. Do you remember what a GCF is and how do you find it? Pause the video and think about this question. When you're ready, press play. The greatest common factor is a factor that divides evenly into two or more terms or numbers. Given 24 and 42, what is the greatest common factor? We should consider the factors of 24 and 42 separately, and then determine the largest factor they have in common. Makes sense, right? Let's look at the factors of 24 on the right side of our screen, on the left side of our screen. The factors of 24 are 1 and 24, 2 and 12, 3 and 8, and 4 and 6. The factors of 42 are 1 and 42, 2 and 21, 3 and 14, and 6 and 7. When we look at these factors individually, when we're looking for the greatest common factor, we're looking for the largest number that the two numbers have in common. So for this case, 6 is the largest factor they have in common. Therefore, the GCF of 24 and 42 is 6. Pause the video and try to find the greatest common factor for each of these pairs. Press play when you're ready to proceed. Let's see how you did. The greatest common factor of 30 and 45 is 15. This means that 15 is the largest number that will divide evenly into both 30 and 45. The greatest common factor between 9 and 27 is 9. This means that 9 is the largest number that will divide into both 9 and 27. The last one looks a little different. This one has a variable, but let's just consider the numbers 22 and 33. The greatest common factor of 22 and 33 is 11. When we consider the variable, the first term is x squared and the second one is x to the 9th. So the greatest common factor is x squared. Now we're going to look at a video example of factoring a greatest common factor. When you have an expression like is given in the video here, 4x cubed minus 2x squared plus 6x, and you look for the greatest common factor from all of the terms, you are doing what is called factoring out the greatest common factor. Let's watch.
Okay, another math video from algebratesthelper.com. And what I'm going to focus in here on this particular video is to help you out with factoring polynomials. Okay, and we're going to start by looking at factoring out the GCF, which is the greatest common factor. So hopefully you're kind of familiar with what I'm going to be trying to do here. And factoring is such an important skill in algebra. You really need to master it. And you can kind of think of factoring as taking something and just writing it in its factors. So for example, if I have 10 and I said factor 10, what I'm asking you to do is to write it as a product of two other numbers, okay, which we call factors. So for example, 10 is 2. I can write it as 2 times 5 because 2 times 5 equals 10. So 2 times 5, 2 and 5 are factors, okay? So if I ask you to factor, let's say 10x, well, you could write that maybe as 10 times x, okay? That gives you 10x. Or you could maybe write this as 5 times 2x. That also gets you back to 10x, okay? So these here would be considered factors. And you can see, this is a real basic example. There's a number of different ways to, number of different approaches to factoring something. And there are oftentimes multiple ways we can write our factors. But anyways, so this right here is 4x cubed minus 2x squared plus 6x. So what I'm looking to do is to factor it in such a way where I have something times something else, and that's going to get me back to 4x cubed minus 2x squared plus 6x. Okay, so that's the objective. And what we're going to focus on in this particular example is the greatest common factor. Okay? So if you're not, this is the first time you're seeing this, I just say go ahead and watch the video once and get kind of used to what I'm doing here. So watch it through. I think after a second or third time, this will all start to click. But remember, what we're trying to do is to factor this polynomial. Okay, so greatest common factor. So this is how you do it. What you want to do is look at each one of these terms in this polynomial. Okay, look at each one of these terms, and we're going to kind of factor each individual term. So 4x cubed I can write as 2 times 2, and then x cubed I can write as x times x times x. Okay, so this one over here, this negative 2x squared, I can write this, let's just kind of keep it as 2 for now, 2x times x, right? That's the same thing as 2x squared. And then 6x, I can write that as 2 times 3 times x. Okay? All right, so greatest common factor. The greatest common factor is the greatest thing that all three of these terms, the factors of these terms, have in common. Okay? So let's ask ourselves, what do all three of these all three of these terms, factors, have in common? Well, they definitely have a 2. Okay? Each one of them have a 2. So because they all have a 2 in common, that's going to be part of our greatest common factor. So that'll be a 2. Now we just have to focus in on the x, okay, the x's. So this one has 3, this one has 2, and this one has 1. But guess what? Okay, the only thing that they all have in common is only one x, because this poor fellow over here only has one x. Okay, it doesn't have 2, it doesn't have 3. So all of them, at least, all three of these terms have at least an x in common. So they all have a 2 in common, and they all have an x in common. And beyond that, they don't have anything else in common. Okay, so 2x is the greatest common factor, all right? Okay, so hopefully that kind of made sense to you. And now what we have to do is to go ahead and use the greatest common factor to factor this polynomial. So what do we do? Okay, well, we're going to write our greatest common factor like this, 2x, and then I want you to write 2 parentheses just like this, okay? And I want you to be thinking to yourself about the distributive property, okay? If I was going to take 2x and multiply it by something, okay, and I wanted to get back to my original first term, which was 4x cubed, what would I have to multiply 2x by? Okay, well, if you think about it, 2x times something, okay, wait, let me just state this in a different way. 2x times something else gets us back to 4x cubed. What would that be? Well, we need a 2 to get that 4, right? And we need an x squared, because 2x times 2x squared will get me back to 4x cubed. So this is the whole idea behind factoring. Now, if you look at it, if I take my 2 and my x out, okay, that's my GCF, well, look what I'm left with. Okay, I'm left with 2x squared, right? So that's what I have here, 2x squared as my factoring. Okay, so minus, okay, we're moving on to the second term now. 2x times what will get me back to my negative 2x squared? Well, I have my minus there, okay? It looks like I only need an x, right? Because here I have my 2 and my x as part of my GCF. So all I need is an x, and I'll throw my negative sign there, so it's a negative 2x squared. So if you think about it, 2x times this minus x will get me back to 2x squared, okay? All right, so like I said, if you're a little lost, just stick with this. Believe me, I've seen students when they initially learn this, they, it's a little tough for most students in the beginning, but after a while, a light bulb will click on. No big deal. All right, so 2x times what else will get us back to 6x? Okay, so just let's go back over here, look at our factors. 2x is our GCF, so 3 is what we need, right? So 2x times 3 will get us back to 6x. So this is the factor here, okay? We just factored this out. 2x times 2x squared minus x plus 3, because if you went ahead and used a distributive property and you took 2x times all three of these things, you would get back to our original polynomial, okay? And 2x is considered the greatest common factor. All right. Okay, so this is kind of like the step one or phase one when you're starting to learn how to factor polynomials. And like I said, I consider for most students, I would consider factoring pretty challenging for them. But anyway.
Okay, so with this video, we learned that if you have an expression 4x cubed minus 2x squared plus 6x, and you find the GCF, then you can bring it outside the parentheses, and basically what you have left in the parentheses is what you get when you divide each of the terms by the GCF. Okay, so hopefully that helped, and remember you can always go back and rewatch the video, but I would like for you to pause this video now and try to complete these three problems, and in this you will factor out the greatest common factor. So once you have done that and you are ready to proceed, hit play. Okay, let's see how you did. In the first problem, you had 21x to the fourth plus 14x cubed plus 7x squared, and you were asked to factor out the greatest common factor. So if you consider 21, 14, and 7, the largest number that divides into each of those three numbers is 7. Then if you look at the variables, you have x to the fourth, x to the third, and x squared. So the largest number of x's you can take from each term is x squared. Therefore, the greatest common factor is 7x squared. When you divide 7x squared into 21x to the fourth, you get 3x squared. So 7x squared times 3x squared would give you 21x to the fourth. 7x squared times 2x would get us 14x cubed, and finally 7x squared times 1 would get the 7x squared. So that one now has got the greatest common factor factored out. In the second one, 18x squared plus 27x plus 45, we find that the greatest number that divides into 18, 27, and 45 is 9. Now, notice in this one there is no variable. And if you look at our original problem, that is because the last term does not have a variable. So you cannot have a variable as a greatest common factor unless each term has at least one variable. And now to the last one, which looks a little bit more complicated, but really it's not when we look at it. If we take 8 and 6 and 4, and we think about the largest number that divides into each of those three, it would be 2. So 2 is the largest number that divides into 8 and into 6 and into 4. Now 4 divides into 8, but remember 4 does not divide into 6, so we can't say that 4 is the greatest common factor. Now let's look at the x variable. We have x to the fourth, x to the third, and x squared. So because the third term only has x squared, that is the largest number of x's that we can take. And finally, y to the fifth, y to the fourth, and y to the third. Because the 3 is the smallest of those three exponents, the greatest common exponent and for the y variable is 3. So for this problem, 2x squared y cubed is the greatest common factor, which leaves us 4x squared y squared minus 3xy plus 2. Now for a brief review of multiplying binomials. Each of these is a binomial because it has two terms inside the parentheses. So in the first one, we would be multiplying the binomial x plus 4 by the binomial x minus 5. So please pause the video and multiply these three pairs of binomials. And then think about what you notice about each of the products. When you're ready, press play. Let's see how you did. When we multiply the binomial x plus 4 by the binomial x minus 5, we get x squared minus 1x minus 20. When we multiply the binomial x minus 6 by x minus 9, we get x squared minus 15x plus 54. And finally, when we multiply x plus 3 by x plus 7, we get x squared plus 10x plus 21. And I ask you to consider what you notice about each of these products. What you should have noticed is when you multiply these binomials, you get a quadratic expression. So notice that we have x squared minus 1x minus 20 for the first one. It is in the form ax squared plus bx plus c. So notice that in this case, the coefficient of x squared is 1, which means a is 1. In the second one, we have x squared minus 15x plus 54. In this case, a is 1, b is negative 15, and c is 54. So when you multiply these binomials, you get a quadratic expression. X plus 4 times x minus 5 is x squared minus x minus 20. Having just done that, what do you think the factors of x squared minus x minus 20 are? And remember, the factors are any numbers or expressions that you would multiply to get that expression. So since we multiplied x plus 4 and x minus 5 to get that quadratic expression, the factors are x plus 4 and x minus 5. Let's review what it means to factor an expression. It means to find the GCF, which we have talked about, and or the two binomials that were multiplied to get the expression. So we just saw that multiplying two binomials will get a quadratic expression. Let's look at how to go backwards. Here's another brief video.
Factoring a quadratic with leading coefficient 1, we're asked to factor this polynomial x squared plus 8x minus 20, and this polynomial is in standard form, descending order, so it's in the form of ax squared plus bx plus c. It's just a little bit special in that a.
Okay, so what we've been talking about for this lesson, and this is not always the case, but for this lesson, we are only interested in factoring these quadratics when a is 1 after we take the greatest common factor. So that's what he's mentioning here. A is equal to 1.
In this case is 1. So whenever we do this factoring, we already know the form that the factoring is going to take. It's going to factor into two binomials. Two binomials, and since the leading term is x squared, that only gives us one choice for the beginning. It has to be x and x, and to find the rest of these, that's where we have to be a little bit more careful. First of all, we need the two numbers to multiply to give us negative 20, but we need them to add up to a positive 8. So two numbers that multiply.
Okay, so what he's describing here is to find the two blanks that would remain in the two binomial parentheses. You have to consider the last term, which is negative 20, and the middle term, which is 8. So he is going to find the factors, the factor pairs of negative 20, whose sum is positive 8. That is the combination he will use in the two parentheses.
Multiply to be negative 20, and those same two numbers have to add up to give us a positive 8. So it's kind of a game to figure out what these numbers are. And if you can think of it off the top of your head, then you're ahead of the game. But let's see if we can find an organized method to find them. Starting off with that negative 20. If I write the factors of negative 20, well, first of all, 20, it could be 1 and 20, 2 and 10, or 4 and 5. Now, in order to get a negative 20, though, the signs on these have to be different. So, different signs. I've written them here as positives, but they have to be different signs. And remember, the other part is that they have to add up to positive 8. So if I'm looking for two of these guys to have different signs and add up to a positive 8, there's only one combination that's going to work, and that's these two. If the signs are different, I could use a negative 2 and a positive 20, and those would add up to positive.
I think there he meant to say negative 2 and positive 10.
Of 8. So just checking here, negative 2 times a positive 10, multiplying gives me negative 20. Negative 2 plus a positive 10 gives me a positive 8. So that's our combination. One of these needs to be negative 2, and the other one needs to be positive 10. The order doesn't matter here, but just to check it and make sure that our answer is...
Okay, he just said the order doesn't matter. Let me clarify that. It does matter if you put the 10 in the parentheses with the negative. That would be incorrect. What he meant was the x minus 2 parentheses could have gone after the x plus 10.
Correct. We should multiply it out just to see what happens. Multiplying the x by both terms, first x times x gives us x squared, and then x times the 10 gives us 10x. And then doing the same thing with the minus 2, distributing it to both terms. Minus 2 times x is minus 2x. Minus 2 times 10 is minus 20. And these middle terms simplify so that we have x squared plus 8x, combining like terms, minus 20. So our factoring did work. Just to write it one more time here, we factored it as x minus 2 and x plus 10.
Okay, so once you've factored out the greatest common factor, which in the last example he did not have a greatest common factor, so other than 1, you should try to find the binomial factors of the remaining expression. Once the greatest common factor is factored out, the remaining quadratic should be in the form ax squared plus bx plus c. And again, for this lesson, a is 1. In future lessons, you will see how to factor quadratics when a is something other than 1. So a is the coefficient of the squared term, b is the coefficient of the middle term, and c is the constant. Now let's look at an example together. We're going to take this step by step. We're asked to factor 2x cubed minus 22x squared plus 48x completely. What this means is we have to go through the process of first finding the greatest common factor, if there is one, and then with the remaining quadratic, we have to factor it into its two binomial factors. So let's start by looking at the greatest common factor. If we consider each term individually, 2x cubed, 22x squared, and 48x, we would see that 2 is the greatest common factor because it is the largest number that divides into each term. And by the greatest common factor, I meant numerical common factor. We have to also consider the variables. So we've got x cubed, x squared, and x. Of those three, x cubed, x squared, and x, the largest exponent that we can take from each of the three terms is x to the first power. So, combining that with the 2, we have 2x as the greatest common factor. If we notice, at the bottom of the screen, we have 2x outside the parentheses, and then x squared minus 11x plus 24. which is what we get when we factor out 2x from each of the three terms. Next, we're going to focus on the quadratic that is inside the parentheses, x squared minus 11x plus 24. We will first look, as we saw in the video, at the constant. So we need to find the factors of 24 whose sum is negative 11. Again, 2x is our greatest common factor. It is outside the parentheses. But now we are going to break the x squared minus 11x plus 24 into two binomials. First, we're going to look at the factors of 24. 1 and 24 is 24. 1 times 24 is 24. 2 times 12 is 24. 3 times 8 is 24. And 4 times 6 is 24. However, we have to look for negative 11 as the sum. 1 plus 24 is not negative 11. 2 plus 12 is not negative 11. 3 plus 8 is not negative 11. It's positive 11, but not negative 11. And finally, 4 plus 6 is not negative 11. So as of now, we do not have a combination that multiplies to give us 24 and adds to give us negative 11. We have to also consider, however, that you can get positive 24 by multiplying two negatives. So if we look at each of the factor pairs as both being negative, negative 1 times negative 24 is positive 24. But negative 1 plus negative 24 is not negative 11. Negative 2 plus negative 12 is not negative 11, but it is positive 24 when you multiply. When we get to the third factor pair, negative 3 times negative 8 is positive 24, and negative 3 times negative 8 is negative 11. So that is the combination that we're looking for. Those two numbers, negative 3 and negative 8, are going to go in the blanks in our two parentheses. Therefore, when we factor it completely, we get 2x as our greatest common factor, and then x minus 3 and x minus 8 as our binomial factors. Remember, x minus 3 could go after x minus 8. Now let's do a little practice before we finish. We're going to be asked to factor these four problems completely. Remember, this means to look for and factor out a greatest common factor if there is one, and then the second step means to find the factors of the remaining trinomial. Pause the video to finish these practice problems, and when you have, press play to continue. Let's see how you did. We have been asked to factor completely. So first we should look for the greatest common factor. In the first one, x squared plus 7x plus 12, there is no numerical common factor other than 1. So notice there is nothing outside the parentheses. We don't have a variable common factor because 12 does not have a variable. So we would say that the greatest common factor for this problem is 1. And you don't normally see that written in front of the parentheses. Look at problem 2. We do have a common factor, greatest common factor for this trinomial. 3 is the largest number that divides into 3, 24, and 60. So we factored out a 3. We do not have a variable common factor because 60 does not have a variable. So if you look back at your work, when you factored out 3, you should have gotten y squared minus 8y minus 20. That means we are looking for the factors of negative 20 whose sum is negative 8. When we think of the factor pairs for negative 20, we know that 1 has to be a negative. So in order to get negative 20 when we multiply and negative 8 when we add, we have to use the combination negative 10 and positive 2. So this one is 3 parentheses y minus 10 and multiplied by y plus 2. And again, you could have y plus 2 before y minus 10, but the 2 may not go in the parentheses with the minus, and the 10 may not go in the parentheses with the plus. So going back to the first practice problem, because there was no greatest common factor other than 1, All we had to do was look for the factors of 12 whose sum was 7. The factors of 12 whose sum is 7 is 4 times 3 is 12 and 4 plus 3 is 7. For practice problem number 3, the same thing is true. There is no greatest common factor other than 1. So we're looking for the factors of negative 32. Because our constant is negative, that means one of the two numbers that we multiply has to be negative. And in order to get positive 14 when we add them, 16 times negative 2 works. 16 times negative 2 is negative 32, and 16 plus negative 2 is positive 14. In the last example, which looks a little more complicated, we have a numerical common factor, greatest common factor, but also a variable. So 4 is the largest number that divides into 4, 48, and 108. And y is the greatest variable that divides into y cubed, y squared, and y. So our final answer here should be 4y, and then parentheses y minus 9, close parentheses times parentheses y minus 3. How did you do? Okay, I feel like we all can use a little more practice with factoring quadratics. So in the resource document below, you will find an assignment, 5A.1, factoring the GCF and A equals 1. Press pause now to complete this assignment and come back and finish the video by hitting play. Let's review. Wow, that's a lot. How'd you do? Let's review what you should have gathered from this lesson. Look for and factor out, if possible, the greatest common factor. Look for the binomial factors. Make sure the expression is in descending order. And by that I mean, make sure the x squared term is first, and then the term that is raised to the first power is second, and finally the constant. That way you will be able to recognize that you do have a quadratic, and you will be able to factor it much more easily. Look for the factors of the constant whose sum is the middle term when the expression is in the form ax squared plus bx plus c. So let's revisit our learning target. We set out to factor a quadratic expression by rewriting it as the product of its two binomial factors. How did we do? How comfortable do you feel? Are you the guy on the left? You got this? Or could you use a little more practice? Don't worry, the resource document below the video has more examples and more practice for you. Feel free to stop the video and take a look at what you can find there in that resource document. Okay, I hope this lesson helps you factor quadratic expressions. For additional practice and support, check out the resources and activities that have been provided in the resource list linked directly below this video. Know that you can come back to this lesson again and again to further reinforce your learning. Reach out to your teacher if you have any question. We're looking forward to a great year thriving together. Thank you for watching.